On behalf of Scott and Chris Ann of Pacific Northwest Rep Agency, we'd like to welcome you and thank you for joining us. My name is Steve Wood. I'm Regional Manager for EWC Controls in your area. EWC Controls, since 1964, we've been manufacturing forced air zone control systems. We're located in New Jersey, and all our products are made in the US. Our focus is the residential market. However, our product, because of the zone panel features, because of the quality, heavy-duty motor, and sizes of our dampers, we can be utilized in the light commercial market. Go to the App Store, search EWC Controls, and download our app. This app will give you features such as the ability to build your zone system. You feed it the information, we will select your control panel, supply dampers, thermostats, transformers, and bypass dampers. Another location, a bypass calculator. You feed us the CFM numbers that we ask, and we will select your bypass for you. There's also an area where you can download all of our tech bulletins or installation manuals of all of our product. Go to our website for some more assistance. We have a video drop down. Select that. You'll see a choice of videos. Here are a few of them. Some of them are instructional, some of them not so much, but all of them will help in the understanding of us and the zone system. Our tech support team. You'll see based on your time zone and our location that our hours are available 5 a.m. to 2 p.m. to you. We stress that you use our tech support number and team for on-the-job urgent troubleshooting calls. We'd like you to have a meter there. We will troubleshoot and find the cause of your issues. If you're not on the job and it's not time sensitive, please use Scott or Chris Ann of the Pacific Northwest, or use myself for any application or support needs. I'm in the Midwest. My hours are 8 to 5. I'm available beyond those hours. So that'll give you a full range of support, full range of hours that you can call for support. Today's agenda, UT-3000 control panel. We will cover that in detail. We'll cover a broad overview on supply dampers, bypass dampers, and then have a little time for questions. Excuse me. Today's focus is the UT-3000 control panel. This panel is the only panel with the communicating protocol that will work with and enhance the operation of Daikin fit communicating equipment. Here are a few things I'd like you just to keep in mind. Anything that you're using going forward with the Daikin 1 stat, please make sure your version, your UT-3000 version is 1.68 or higher. That version number is located on the outside of the box on the sticker with the panel model number. If you have a 1.5 or higher, you can still use it on the Daikin fit. It is just not compatible with the Daikin 1 stat. So those are the two things to remember. And both of these products and anything higher than 1.5 will work on any previous product prior to the fit development. The zone control panel, and let's take a tour around this board. The zone control panel becomes the thermostat. What does that mean? That means that the equipment believes you're tying it into a thermostat. The same exact wires that you would run up to a thermostat in a non-zoned application are the same wires that you run to this zone panel. In this particular case, you're bringing your 4 communicating wires up from your zone, air handler and or furnace, connecting it into the communicating terminal in the lower left-hand corner. Here's just showing a few applications, examples, wiring examples. And note that we never bring the outside unit to the communicating panel. The outside unit connects to the air handler furnace just as it does in any other non-zoned application. Above that is a dry relay output terminal strip. This has a couple of different options. One, it can be used for IEQ, which I'll show you here in a bit. The other is this panel could be used in an emergency. If you didn't have a panel available, this could be used in a 24-volt non-communicating application. In a non-communicating application, it becomes a 2-stage heat, 1-stage cool zone panel. Again, only for emergency needs would I use this panel in a non-communicating application. Above that, the Ieq Relay. This is where I again have the option to tie in third-party Ieq products. Some examples. Here you're noting I'm tying in a whole house humidifier and an outdoor fresh air damper. Both of these need to see a demand from one of the zones and or a heating, cooling, or fan call from one of the zones. Another application, again, that we need to see a demand from the zone thermostat to utilize operation of the humidifier, and we need to see a heating, cooling, or fan call to utilize the ERV, HRV. If we are just using the Ieq relay and I want to communicate to that, this is just an example showing that I am tying in the communicating or programming the communicating thermostat to trigger the Ieq relay and start the ventilator. Now we come to our zone terminal strips. On those zone terminal strips, you will see a 24-volt terminal strip, thermostat strip. You will see a communicating thermostat terminal strip, and you will see a zone damper terminal strip. That is the same set of terminal strips at each location. An example of our dampers tied into this board. In zone 2, you see I'm just tying in straight one damper to one zone. Zone 2, 3 wires, power open, power close, and common. Zone 1, I've utilized the ability to have 3 dampers tied into my zone. I'm daisy chaining those 3 together and coming back to the panel one time. I can connect up to 18 dampers. Now, if I'm connecting multiple dampers, our suggestion is that you home run more than one time. In fact, we require you to home run more than one time. So don't daisy chain 18 together and bring it back from the last damper. Utilize the ability to get 3 wires into our terminal. So each one of those, the common power open, power close, will accept 3 18-gauge wire. So that gives you the ability to always, in multiple damper setups, applications, to home run up to 3 times instead of daisy chaining them all together. We recommend that once you get in the 8 to 9 damper range, 7, 8, 9 damper range, to start home running more than once. If you're using a spring damper, spring dampers are a little different ability in the sense that they draw 400 microamp. Our terminal output at each one for dampers is 500 microamp. So directly tying a damper to that terminal strip allows you to do 1. Our power open, power close dampers only pull 26 microamp. That's what gives you the ability to tie in up to 18. If I come to a job site where I'm using the existing dampers and they happen to be spring dampers, as long as I have 1, I can tie directly per zone, I can tie directly into that zone. If I would happen to have more than 1, you cannot tie all 3 into that zone terminals you need to use a third-party relay and transformer, such as you see in the wiring diagram, to power those dampers prior to connecting to the terminal. If we look at the thermostat terminal, and this is the different options that are available, you'll see that I can accept multiple options at thermostat. I do not have to use a Daikin 1 in all zones. It is recommended and highly recommended that you use a Daikin 1 stat in zone 1. If you look at some other examples here, I've got a non-communicating heat-cool stat in zone 2. I'm utilizing an heat pump stat in this particular example, Wi-Fi stat, and the wireless stat, all with the Daikin 1 stat in zone 1. Zone 1 terminal strip, the dry output does have a couple of other features that the other terminals, zone terminals, do not have, and that is the one zone mode. This gives me the ability to tie in our particular accessory and utilize the ability for this to operate in one zone mode. Why would I do that? If I'm going away for a period of time, long weekends, vacations, rather than go around and switch all thermostats, either change program or set them down or turn them down, I turn this switch, that takes it out of the zone mode, and the entire structure and dampers operate off zone 1 thermostat. When I return, when I want to put it back into zone mode, all I simply do is turn the switch off. There is the Ieq Relay on this zone terminal as well. Here I'm using a third-party CO2 sensor to activate my fresh air damper. And keep in mind, I must see a fan call for that to happen from one of the thermostats. I cannot energize a fan call with a third-party non-communicating control, excuse me. And in the bottom right is where I connect in my outdoor air sensor and my supply air sensor. Now, I may or may not need an outdoor air sensor. The only time I should need that or would need that is if I'm using a piece of non-communicating equipment outside, non-communicating heat pump. If you're using the Daikin Fit communicating, that has a built-in outdoor air sensor. I do not need to add an outdoor air sensor. Supply air sensor is a must. That comes with the panel. That's what communicates the discharge temperature and helps entirely required for the operation of this product. So I must install that supply air sensor. Where do I put it? I put it in the main flow. I put it close to the last item in that chain of heating cooling products. So this needs to be after the last heating product, and it needs to be after the last cooling product so that it can properly read the temperature in both heat mode and cool mode. Supply air sensor, again, if it's needed, is typical to any outdoor air sensor. I'm going to mount that on the outside, wire it back to my outdoor air sensor terminals. Now, we do give you a probe in that box with that outdoor air sensor. You can use that probe as you would in a supply air sensor installation, and you can mount that rather than the outside and deal with the sunlight and indirect temperatures and so on. You can, in snowfall, you can put that right inside the sill plate on an incoming fresh air damper, excuse me, a fresh air duct, or a fresh air intake for either my water heater or my furnace. It allows you to cut that probe to a length that will fit in any of those choices. Then I have my dip switch down at the bottom, these dip switches are not used for any of the setup. It is used for troubleshooting, which we'll get into later, but they're not used for any setup or configuring on this board. And then I have my polyamp. We do not have a fuse on this. I've got a 2.5 polyamp. That will protect me from shorts in my 24-volt wiring or my thermostat wiring. If that should detect a short, it will get hot and pop open. At that time, I need to go around to those terminals and disconnect the power wire until this board fires back up. At that point, I've located my short, I fix it, correct it, I will reset, and I will be up and running. My LCD screen, this gives you various readings. It scrolls nonstop unless you manually stop it, and it gives you different readings. If I want to change some settings, some default settings that this board comes set up as, I can use those switches or those pot switches to navigate. If I want to stop and observe a particular setting, a particular reading, I can navigate to that and stop it for a period of time to observe it. Some of the readouts that you get from this are just that. They're readouts telling you what's going on and if it's going on and what's going on in each of the zones with the system demand, with any auxiliary, with any Ieq products. Most importantly, it tells you on the fly supply temperature so that you can monitor that and see if the equipment is operating properly based on the supply temperature and so on. Some new things that were added is just more information that will tell you in an LCD printout what is going on at any particular time. Excuse me, not a printout, but an LCD scrolling message, what's going on at any given time. This is our program settings, and this is what we use to operate. These are settings that allow this to function in the manner in which we want it to. As you will note, there's three columns. There's the feature that we're talking about referencing, and there's a default, meaning the out of box setting that we send that to you and where it's at. And then there's the ability, the range to select, the ability to change that default setting. So as we go down through these very quickly, we look at system type, heat cool. If I want to change it, I use the pot switches, go to heat cool, and I change it to heat pump. Any of these, I use the pot switches, navigate to that location and change it to one of the areas that you see or one of the parameters that you see on the right-hand side. Thermostat type, heat cool or heat pump. Note that all thermostats have to be heat cool or they all have to be in heat pump mode. You cannot mix and match. Reversing valve. Then I have fan mode. Is my fan energized immediately upon a heat call, or is there a time delay? Gas, of course, is going to give you the normal time delay. Hydro, hot water, or electric is going to give you immediate fan. Outdoor air sensor, am I using it? If not, and I come out in the box with it set to off, if I'm using it, I must go to that and select a temperature between 7 and 42 degrees that I'm going to bring on auxiliary. OT offset, UT offset, target temps, and response delay. These are all somewhat working together. I'd like to go through them as a bunch. First of all, the target temps. These are temperatures that my supply air sensor are looking for to achieve to satisfy a heat call or cooling call. I want to see that call. Once I'm there, I stop the equipment from the process of either staging up or staging down. If I achieve that particular target temp, that's the temp that I'm comfortable with that will take care of that call in a timely manner. So in the OT offset, that is a high limit protection. What it's saying that, and we've selected 8 degrees higher than either one of my target temps will cycle the equipment off. It's my high limit. I'm sensing too high heat. I will cycle it off. I will do that for a period of 3 minutes. At that time, I will make sure the temperatures are safe to operate again. And if there's still a heating call, I will bring that back on. In my cooling, I've got a UT offset of 7 degrees. So that means that if I see a temperature down to 40 degrees, I'm going to cycle off that compressor before it ices up, freezes up, and before it slugs back to the compressor. And again, for a period of 3 minutes, and if the cooling call is there and my temperature is safe to operate again, I will bring that cooling call back on. Keep in mind the fan is running during all of this cycling. So it's not a nuisance fan off, fan on operation. It's just the equipment itself, combustion and or compressor that are cycling. My response delay is how often my supply air sensor is looking at the target temperature and feeding that information back to the UT-3000. And I'll go through that operation where that makes a little more sense. But again, I'm going to look every 22 seconds and I'm looking to achieve 112, 142, or 47. If I haven't, my system demand goes up, and system demand is part of the operation that allows me to stage up or stage down the equipment. And I'll show you that here in a bit. We get to the rest of the settings. The W2 threshold, this is a percent, and this is a formula that we're looking at. This is a percent of system demand that we get in heat pump operation where we bring on auxiliary. This will make more sense, and we'll review this in a bit here, but when I get to 95%, if I have not seen my target temp or achieved my target temp, I will bring on auxiliary. And you'll see that you have a range of 65% to 99%. So that may be something you adjust in the field. Purge fan, that means once the call is ended in that particular area, my fan operation is at what speed. When I'm purging, I bring the fan down to a 50% operation during that purge time, which is 180 seconds. So at the end of a call for 180 seconds, I will bring that fan down to a 50% level. Then I get to my weight features. And again, this is part of the operation, but this gives me ability to weight my zones based on the demand and or size of that zone. So it's a combination. The more demand, the larger that zone is, the heavier weight I'm going to need. And that gives the zone panel itself the ability to supply less or more firing rate to satisfy calls in those areas. We'll get into that in a bit. The total zones, am I a 2-zone or 3-zone? Limit my supply air sensor. In this particular case, no means I want to use my PID loop. I do not want to limit it. If I select yes, I take PID out of the equation. The PID in another sense is the algorithm formula to all this operation. I'm selecting no because I want to use it. I want to use the feature that is available to me to help this operate and satisfy calls. Damper default. When this system is sitting idle and my damper's closed or open. And my W2 lockout, which is important in some states where it's code, which is a temperature that says you cannot bring on auxiliary if the temperature is X or higher. So you have to know that where that number is, and that's the number you plug in there. And that means that they want you to utilize the heat pump at this temperature and below, or excuse me, at this temperature and below, do not bring on auxiliary if it's above 50 degrees or 60 degrees, whatever that code says. So in review, remember we selected no. We're going to allow this PID loop to help us operate and stage this particular equipment. If we look at our target temps, 112, 142, 47, these are temperatures we're looking for in the supply plenum to satisfy the calls in their particular areas. Response delay is the time that we've selected that in real time, how often is our supply air sensor looking at the temperature and feeding that information back to our panel. And then our threshold, when do we bring on auxiliary? So let's take a look at what our PID loop does. And this is when we're using our PID loop. So think of this whole thing as a formula. These percents that you see are not the percentage that your equipment is operating at. These percents are part of a formula that help determine whether you stage up or stage down. So with that in mind, we look at example 1. In the first column, we've got the assigned weight. Well, zone 1 is calling, and it's a 70% weight value that we gave it. And we're getting a 30% demand from our, a demand of 30% from our thermostat. That means that we have a communicating thermostat in zone 1. Why? Because a communicating thermostat has the ability to give you the following demands: 30%, 60%, 75%, or 100%. What determines what kind of demand it gives you? That is based on how far away our actual temperature is in that particular area as to the setting on the thermostat or what it's trying to achieve. If I'm within 1 or 2 degrees and maintaining that, you're going to get a 30% demand. If I fall below that, you could possibly get to a 60% demand. And if I'm going into a setback, a deep setback, or a semi-deep setback, you could see the demand of 75% or 100%. I need to recover 6, 8, 10 degrees. So you're going to get more of a demand. What I do in this case as part of the formula is I take the demand times the weight, and that gives me a starting point of 21%. That means I'm going to start my system up, my equipment up, with a demand of 21%, not with a firing rate of 21%, but with a demand of 21%. In this case, I've got zone 2 calling as well. Now, zone 2 weight is 15%. My demand in that area is 100. Now, you'll see 100 for 2 reasons. One is, like I mentioned, we've got a communicating thermostat, and we've got a large degree of setback, which would be somewhat ridiculous, but that could give you 100% demand. But in most cases, you will see 100% demand because that is a non-communicating thermostat. A non-communicating heat-cool thermostat can only give you 100% or 0%. It does not give you the information, the demand based on the set point and or the temperature it's trying to achieve. It gives you on or off, 100%. So 100% times 15 is 15. Now I add zone 1 and 2. My starting system demand is 36%. And I'll show you what that means here in a minute. What's 36%? But that's where I start, at 36%. Now my PID loop gives you a range, meaning I start at 36, but what do I do from there? With the PID loop staging range, that means I will maximize times 3. So I take 36 times 3. It means if I have not satisfied my call and have not reached my target set point, I will go all the way to full demand. which is full stage in whatever equipment I'm using. If I didn't have the PID loop in here, I'll show you what happens at that point. But because I have it in there, I'm not going to get to a point where I do not satisfy this call and I run and I run and I run and I run. I need to stage up at some point, if necessary, meet that target temperature and take care of this call. So that's why the PID loop says, I'll give you a staging range of 3 times your starting demand to make sure you satisfy this call. Down below in zone 2, very simply, example 2 is a 2-zone system. It's calling in zone 2, it's calling 30%, which means I have a communicating thermostat in zone 1 and 2 here. 1 is not calling, 2 is giving me 30% times my 35, which is the weight I gave it in this example, gives me a starting system demand at 11. 11 times 33, or 3, gives me 33%, which means I can go no higher than 33% to satisfy that call. What's that relevant? See, I'll show you here. This hopefully makes more sense. So we look at a 2-stage piece of equipment, whether it's heating or cooling. First stage in our heating and cooling equipment with 2-stage equipment is 70%. Quite simply, it cannot run any lower than 70%. That's my first stage. So in the example above where I started at 36%, that means I'm between 10 and 51 on my formula. I start at 36%. In 22 seconds, I'm going to take a reading and I'm going to see if, and let's say that this is the heating target I'm looking for. I'm going to see if I'm at 142. If I'm not at 142, I go up to 37%. 22 seconds later, I go up to 38. 22 seconds later to 39, and so on. Once I see my target temp of 142, I stop my percentage at that particular point. If that's at 48, I stop at 48, I stay at 48. If I happen to go slightly above that 142, I will stage back down 2% in 2% increments. I go up in 1% increments, I go down in 2% increments, and settle in where I'm achieving and maintaining that 142 degrees. If I did not reach my target temp at 142 at 48 seconds, I go to 49, 50, and I hit 51. 51% based on this formula pushes my equipment into stage 2 or 100%. So I go from 70 to 100% at that time because I did not reach my target temperature. So that's the relevancy to the percentage based on what does that do for staging. That's how it works in 2-stage equipment. Now, if I was in a heat pump operation, outdoor heat pump, I reached 51 and I did not meet my target temp of 112, I kick in second stage. At that point, I still keep going up until I see my target temp. I can go up 52, 53 in 22-second increments until, if at some point I get to 85% based on this particular setting, note in the default settings it said 95, and this we show 85. If I go up in 22-second increments to 85% and I have not reached my target temp, I bring on auxiliary, which is either my dual fuel and I drop Y, or I keep Y energized and supplement, one of the two. But that is the formula that it determines how I stage in 2-stage equipment. Now, if I look at modulating equipment and inverter operation, a little bit different. First of all, my modulating furnace Now at the lowest stage is 50%, not 70%. My lowest continuing operating firing rate in a modulating furnace is 50% with a fan around 60%. That's my lowest operation. So if I come on at 36%, I'm still at 50% until I get to that point. If I do, where I haven't reached my target temp, I hit 51%, I take my equipment to 51%. I hit 52 because I haven't seen my target temp, my equipment goes up to 52%. I'm now in sync with the staging of my modulating equipment. Every time I go up 1%, my stage goes up 1% until I achieve the target temperature. In a heat pump operation, modulating, I can, or air conditioner, I'm down to 35% is my lowest operating percent firing rate. So if I start at 36, my heat pump starts at 36. At 22 seconds, if I do not see my target temp of 112 in heating mode, I go to 37%. My inverter goes to 37%. So we're already hand in hand and we're climbing together. Once again, I climb all the way up to 85 in 1% increments and I haven't hit my target temp, I will energize auxiliary. So that's the relevance of our system and what those percentages mean. Now, if I look at that loop and let's just say I selected Y, I do not want that PID loop involved. I want to be very specific on how much demand, what stage I'm going to give those zones. I don't want it to have the ability to go into a higher stage than what I feel is necessary for smaller zones and or to satisfy my call for minimal amount of zones calling. I decided to take the loop out of it. I would be very careful doing that. I would always let the loop be a part of the operation. I would almost always select N unless you fully understand what's going to happen if you select Y. And this is what happens, and I'm showing you this so that you know exactly what happens. You'll see that I do not have the multiplier of 3 anymore. I'm going to get a system demand of 36%, and that's where I stay. I cannot go any higher. So I go to 36%. That means I'm in first stage on multi-stage. I cannot go to second stage. Now that may be fine. However, if I'm in that large zone, like you see, the 70% weighted zone, and my homeowner is using a setback, and it's a worst case scenario, heating or cooling day where it's very hot or very cold, and I've got a lot of temperature to recover, I've got to do that in first stage. And you'll see down below it's 11%. So it means I'm always in first stage as well with either one of those zones. In the example 1, I would have to see zone 3 call to get enough weight to take it into second stage, to take it beyond 51%. So only when all 3 zones are calling, which probably means I've got an extreme temperature one way or another at the time, will I have the ability to go into second stage when I'm taking the loop out of the equation. Now understand that I start in either one of these examples, I start at 36% because 2 zones are calling. So I start in first stage. If I would happen to get into second stage and one of those zones satisfies, my system demand immediately drops because it loses the value of the other zone, and it's now operating and based on its own value, I do not need all that firing rate to meet that target temp for one zone. So you will drop, and accordingly, if that gets you into a stage or below the percentage of 51%, you will drop it back into first stage. If you're using a modulating or inverter, you will drop down in 1% increments to the lowest, not to exceed the lowest operating firing rate, but you will drop back based on the number of zones calling. So as the system demand changes, so does the percentage, and so might possibly the staging. We do not control the blower. Those questions are asked all the time. Why, when, or why can't you control our blower so that we don't need to use bypass, or that we can slow it down based on the zone or number of zones calling? Equipment manufacturers are never going to let us control, or you control, minimums on a blower. They're not going to allow you to possibly set up a train wreck and cause warranty issues. So they'll give you some parameters. In this case, they give you a couple, and you go to the thermostat and to work with that blower CFM based on the zoning and based on the sizes of your zones. It'll give you the ability to change the CFM operation to a degree. And here are the profile settings, and what this is dealing with is temporize, and that's how they're going to control that blower based on the stage you're in, and based on the temporize is where they're going to, where that blower is going to operate at, regardless of where you'd like it to. So you can select one of those temporizes, and you'll note that if you're trying to lower the CFM to a minimal, you're going to want to select the 70 or the highest degree of rise to get the lowest CFM. The other setting is the positive or negative trim settings. So these blowers are based on 400 CFM per ton. In the setup, it allows you to give that a positive setting of plus 10, 12, or 15, meaning I could go up to 440, I could go up, excuse me, I could go up to 450, I could go up to 460 per ton. It also allows me to lower that blower CFM and to go negative 10, 12, 15, meaning I could take it down to 340 CFM per ton if I'm trying to lower the CFM at any given time during my operation for one of my zones or for all of my zones. Part of the other setup here is we highly recommend that you do a bias test upon finishing your installation. What is a bias test? Well, you got to understand we're dealing with data communication here. Very, very important that we maintain communication. So what they're looking for here, or what you're testing for, is that you have properly connected to the terminal strip. So you got a secure fitting. You've got a secure, tight fitting if you've used any wire nuts. This will ensure that if you're getting these readings, that you have done a good job. You can pat yourself on the back for doing a good job of wiring, and that you're going to get proper communication. Improper communication will obviously give you sporadic operation and nuisance calls from the homeowner, nuisance operations. And so if you don't do it on the immediate fire up, you'll eventually do it and find that there's somewhere in that wiring part of my installation that is not done properly. That is all done in this location is where you're going to do all that testing. The bias is where I look at to make sure And that's all you're doing with this particular dip switch block, is making sure that all of these switches are to the left. They all need to be off. All the switches on the bias block out on the outside unit need to be off. That's the way they should come from factory. They should be checked to make sure they didn't get put in the wrong position or bumped in some fashion that one or more of them might be in the on position. I do my bias testing here. Everything checks out. I'm good to go. We also have a procedure that's required. It's required the first time on startup that you have a Daikin fit in zone 1, excuse me, a Daikin 1 stat in zone 1 to do this inverter startup procedure. We give you an addendum in that installation manual that'll walk you through that startup procedure. Again, it has to be done once. It would not have to be done again on that unit. But the very first time it's commissioned, you need to go through this procedure. And it needs to be done from zone 1 with a Daikin 1 stat. Just released to you, I believe around 3 weeks ago, was the ability to twin, which now we can go up to 5 zones. We did put an addendum in with these UT-3000 boxes with the installation manual that goes through the information on how to twin these. So you'll note that we'll use identical boards. One's a master panel, one's a sub panel. We do not end up with 6 zones. Even though we're using 2 3-zone boards, we end up with an additional 4th zone or an additional 5th zone. The 6th zone will be utilized with connecting these 2 together or twinning it together. So zone 2 or zone 3 will be used to twin. So you lose that particular zone, which now takes this twinning down to a 5-zone max. That's our UT-3000 panel. Now we look at supply dampers, and quickly a broad overview on these. These are the dampers you use with this product. It is the same exact damper you use for your non-communicating zone systems as well. And that's one of the beautiful things about that. You're not looking at a high-end communicating motor actuator specific damper to use with this product. We have these dampers available in rectangular, side mount, and bottom mount. These dampers come from 8x6 up to 30x30, all even sizes. We also make odd sizes, 12x11, 13x11, 16x9. We will custom make those and get them out in 3 to 5 days when we're in a normal manufacturing period of time, which unfortunately right now is not that period of time quite yet. But we do make custom. So if you're in those applications, keep that in mind. All the even sizes are stocked. They're in our book, in our catalog, and those are ready to go in roughly 2 to 5 days. Round dampers, and note that we use the same exact motor actuator on all of our dampers. Round dampers are available in 4-inch up to 20-inch. Every size that round pipe comes in. That's right, even odd sizes. This application, of course, is when I'm building round duct and or I'm using flex duct. If I'm using hard duct and I come into a retrofit job that I'm using hard round pipe, I do have a slip-in retrofit damper that allows me to put multiple dampers in to every outlet to create zones in that fashion. So I cannot use a dedicated main trunk because there's dampers, there's outlets coming off that are going to all different areas. I can now utilize a retrofit damper and hand pick the supply outlets that go to my zone 1 and tie those together. I can hand pick the supply outlets that go to my zone 2 and tie all those together, and I build my zone system that way. Bypass dampers. Our bypass dampers, we have the one and only SBD bypass. It is a smart bypass damper, automatic setup. It's a Belimo actuator with a built-in magnehelic gauge or built-in pressure regulator, and we will set up your bypass automatically with the push of a button. We do need to obviously select size and determine what our bypass is. Once we have that done, we'll take care of the rest. We have mechanical dampers, bypass dampers, round and rectangular. And they quite simply just require that you use a different little different setup mode, either dialing in your bypass static with the round damper or adjusting an arm and a weight to adjust your static on your rectangular. When I use a non-electronic or a mechanical, as I just showed you, highly recommended that you use hand dampers. In the bypass training class, I will go over bypass much more in detail, both the operation setup of all of our bypass dampers. I will do the same thing for supply dampers, and I'll do the same thing for our non-communicating zone panels. As far as today's training, that's all I've got. I thank you again all very much for joining me, and I look forward to seeing you in upcoming classes.